Hello and welcome. In this example, we're going to look at how to calculate power consumption using Ohm's law and the power law. In this example, they've given us 25 volts battery is connected to a 1.33 kilo ohm resistor. We see that down here in this circuit. How much energy is consumed in 17 minutes? Remember, energy is work. So we're aiming at work. So we can circle that on our upper thing here as well. We can rearrange that equation and say that our work value, W, is equal to our power times our time. They didn't give us power though, and they gave us time. They gave us time in minutes. And we know that we're aiming at joules, so we'll have to get that minutes down. So we can say that our time is equal to 17 minutes. And we want to make that into seconds. So we can calculate that out. We can say that we have 17 minutes multiplied by the number of seconds in each one of those minutes, 60. And we'll be left with 1,020 seconds. Right, now we need to figure out what our power is. So our power, let's go to our laws over here. We were given voltage and resistance. So we know voltage and resistance, and we don't know current. And we know that the power law needs both voltage and current to solve out, right? And so we can solve for each. We can say that the current in this circuit is equal to voltage over resistance. And we were given both of those. So we'll plug that in. 25 volts divided by 1.33 k ohms, right? That's kilo ohms. And so we can even rewrite that outside of that notation. We can say 25 volts divided by 1,330 ohms, right? And now that's at base again. And so if we solve for that, we can find out what our current is, and we can plug that into our power law, because our power law says that power is equal to voltage multiplied by current. So that's our next stage. Power is equal to I times V. We know our voltage. We're going to solve for our current. We'll plug that into our Desmos. We'll say that we have 25 volts divided by 1,330. And that gives us a tiny little current. That's what we expect. Current is usually pretty small. And so we'll move that decimal point over and round. So we'll write it down here, 0.018. That 7 is going to round up because of that 9, so it'll be also an 8, and that's in amps. And so we want to make that into notation here. And we can move that over 1, 2, 3, and put our decimal point there. That's our -3 location from our base, which means that we have 18.8 milliamps. So now we can multiply out our power. The power is going to be equal to our current times our voltage. We know our voltage is 25, so we can say that we have our current value of 18.8 milliamps multiplied by our voltage of 25 volts. So watch out for this notation in these. Sometimes it's easier just to leave it at base for your current, 0.0188. That way you don't have to deal with the milliamps in this power calculation. So let's send this out. We can calculate that. We've got 0.0188, that's our current, multiplied by 25. So that would be our power right here. So our power is equal to 0.47. We can move that over 1, 2, 3 locations to our -3. You have to add in a 0 there, right? So now we're left with a power of 470 milliwatts. Right, that's not our final goal though. Our final goal is actually our energy. So we're going to go back up to our original equation here and plug that in. We can say that work is equal to power times time. We got our time value and we got our power value, so we can plug that in. We can say work is equal to our 470 milliwatts multiplied by our time value of 1,020 seconds. And those two together is going to give us our work out. So let's plug that into our Desmos here. 0.47, that's our power value. We'll multiply that by 1,020, and then we are given our work in joules. 479.4 joules. All right, let us know if you have any questions.